Hello, my great students. I welcome you once again to this learning. And today we are going to be treating a little topic termed harvesting of solar energy. If we recall vividly, in first term we did the concept of work, energy, and power. And under energy, we were able to define energy, and also we listed the different forms of energy, which solar energy is inclusive. Now, today we are going to be looking at how we can harvest this solar energy and use it in our homes. Okay? Now, the first heading we have on our screen there is the production of solar energy. How can we produce solar energy? God has given us this, and it comes from the sun. We don't pay for it. God has given us the sun. Okay, we have there that the sun releases to the earth a huge amount of energy, and this energy is known as solar energy. And that this energy is produced by a process called nuclear fission. Nuclear fusion. In SS3, we are going to be looking at nuclear reaction, where we are going to look at two different types of this reaction, which include nuclear fusion and the nuclear fission. And for this fusion, it's just fusion to fuse together. So we will be looking at two light elements coming together to form a heavy one. Okay, till then. Okay, let's go ahead. The high temperature in the sun makes this nuclear fusion possible. This energy is released in the form of light and heat. Most of our other forms of energy comes principally from solar energy. And how can we collect this solar energy? Solar energy is collected by a large concave mirror and concentrated on water to produce steam that drives steam turbines. Remember, we have already treated the production of electric current. You remember during that study, we were able to look at different ways we can produce electricity or electric current, and one is through dams. And how do we produce through dams? It's through what? Steam turbines. And when we do that, we can produce large current. Okay. Some are also collected by solar panels on roofs of houses for domestic heating purposes. Okay. Now, we have two kinds of devices we can use to intercept the solar rays and convert it to what? Thermal energy. And these two kinds of devices, one is the flat plate collector, and the second one is the focusing collector. Most of us are already conversant with it, and some of us we have them in our homes. On top of our roofs, we have the first one, flat plate collector. Okay, now let's look at the flat plate collector. We have that it is a large shallow metal box typically mounted on a roof or a high stand that heats water using solar energy. It is usually designed to operate in low temperature range, starting from the ambient or surrounding temperature to about 65 degrees Celsius, or in the medium temperature range from ambient to 100 degrees Celsius. And these flat plates are designed to have heat delivered at low cost for long periods. If you look at your screen, you will be seeing the diagram for the flat plate collector. It's also in your new school physics. If what you are seeing there is not all that clear, you have it in your new school physics. You can see the rays of the sun coming, and we are having glass or plastic cover plate. So once this rays comes, what happens? You also have other components there. When it heats up this panel now can convert this solar radiation to what? Heat energy. Convert solar energy to heat energy or thermal energy. And that's the function of this solar panel. And we can now use it to heat our water in our homes. Then if you wish to use it for the production of electricity, then it means that you require a steam turbine. As the turbine is rotating, current will be produced. Okay. Now the second diagram we also have is what? The one you will see on the roofs of some buildings. And you can see how it actually looks like. You see the solar radiation coming and other components of that flat plate collector. Okay. Now the second type, which is our focusing collector, uses a concave reflector. That can be a mirror, it can also be a lens to concentrate the solar beam. In this way, the intensity of the beam is raised from 2 to 10,000 times. And that this high intensity radiation is focused on the black absorbing surface receiver, which is an insulated to reduce thermal losses. It is insulated to reduce thermal losses. And that because of this high concentration of solar energy, the temperature of the absorber is raised up to 100 to 2,800 degrees Celsius. You can see how high this temperature has been magnified to 100 to 2,800 degrees Celsius. The focusing collector must be movable. That is very, very important. It must be movable so that it can always be oriented to gather the sunlight. So it must be movable. So if the sun rays is facing this way, you can now move it to that to trap the rays from the sun and be able to convert it to what? Thermal energy. Okay. Now let's look at the diagram we have there. That's a simple diagram. You also have that in your new school physics, and that is a focusing collector, and you can see a parabolic mirror reflector there, and you have your absorber inside. So the reflector reflects the sun rays from the sun and now focuses on the absorber. And if there is a connection, this absorber will now direct what? The converted solar energy to heat energy to your what? To your homes for heating of what? Water. Okay. Now the second diagram there we have is also focusing collector. You can see that also. We have the reflector there and the rays of the sun coming, and the reflector reflects it back to that where you have an evaporator. The evaporator can serve as what? A kind of absorber, and you can see the channel there. It moves from there and now condenses. You have a condenser there, and from there you have your what? Distilled water. All right. So that is a little introduction or discussion to that topic, because it's just a simple topic and very small. So what are we supposed to know here? We have to note the two kinds of what devices we can use to trap the radiation from the sun and use them to convert this radiation to thermal energy. And we should be able to know the components of these panels. The next heading we have there is application of solar panel. Application. Where can we use this solar panel? And the first thing here is that the main use of solar panel technology is for providing a cheap and clean source of hot water. A clean and what? Cheap source of hot water supply. And when you have this, you can now use this in homes with a large family or in hospitals where hot water supply is in high demand. And secondly, commercial application include the use in big laundry establishments, big hotels, car washes, military laundry facilities, and in cafeteria and other eating houses. Thirdly, solar panels are also used to heat swimming pools. Yes, in cold weather. In cold weather, you can use solar panel to heat up your swimming pool, and you can also use it for what? Space heating. When the weather is cold, if you have an auditorium or a hall and the weather is very, very cold, you can now use this solar panel to heat up that auditorium or the hall. Okay, we have the fourth one there. Heat from solar panel is used for evaporation of salt water. Very, very important. Evaporation of salt water to produce salt. When you have, if you collect a sample of salt water and now concentrate this solar panel, or either you're using the focusing collector, you now focus the reflected rays to this salt water. What happens as time goes on? The water will evaporate, and you'll be left with your salt. Okay, and for distillation of salt water, or we call it brackish water, to produce clean drinking water. Yes, distillation of salt water. Distillate the salt water and you have your clean drinking water. And finally, which is of great importance to us, we can use this solar panel for electricity supply. And that is where we are going to stop for today till we meet in our next class. And I'm going to be leaving us with this little assignment. Number one there, what are the functions of the various components of a solar collector? You will see this in your textbook. Just look at the components there. What are the functions of the various components of a solar collector? And finally, number two, what are the advantages of solar energy over other energy from fossil fuel? Okay, thank you for listening, and remember to stay safe till we meet in our next class. Bye.